Welcome. Let's take a look at what happens when we use parentheses versus when we don't in math, with derivatives, that is. So imagine we have the following expression, x squared plus x, but the x has over here a little apostrophe. Now remember, this apostrophe in this context, this little symbol means prime. It means you should differentiate the expression. But now let's look at this very carefully. This expression doesn't have parentheses. That means this little prime up here, the little prime symbol, that applies only to the x here, and nowhere else does it apply. Okay, right here, it applies to this x, only that x. So when you differentiate, that means you're going to copy the x squared completely unchanged, but then you're going to differentiate just x. The derivative of x is 1. So you have x squared plus 1 as the result of differentiating using the placement of prime here as you see it. So I can get rid of this common here. We don't need this so much anymore. But now, what happens if I first put up parentheses? Now, let's think about this. You put up parentheses. You're beginning to consider the idea you're going to group some things into a unit. That means, in other words, you're going to begin to apply the same operation to every member of the expression, every term in the expression. So imagine it says x squared, just because we feel like it, plus x. Now remember, a principle in math is balance, opens and then closes with parentheses, right? So you're going to open here and then you're going to close with the matching parentheses on this side. Now it looks balanced. Look at it, right? And then the prime will go up here. So this means the prime should be applied to the entire expression, but what that really means is it should be applied to each part of the expression. So that means you can put, for example, a way to think about it is you put a parentheses, you put x squared, and then again, to maintain your balance, you close the parentheses, and you put its own prime, plus, open parentheses, for example, put the x in there only by itself, close the parentheses to maintain the balance, and then you put a prime. That means you're going to differentiate these two terms independently. So the derivative of x squared is 2x, and the derivative of x is 1. So now let's compare these a little bit carefully. They're not the same, clearly. This has x squared, this has 2x, so these are different. That means clearly like x squared is not the same as 2x. These two things look different, they're different expressions. But what is the same is the following. Let me make this green here, is that this is 1 and this is 1. So these parts are the same, right? The 1 equals the 1. So this is important to remember that when we have parentheses, the meaning is of one type. A similar looking expression without parentheses, but the prime is applied to only one term and you get a different result. So parentheses change what we mean in math. Thank you so much for watching. I think it's useful to go through life and keep your mind maybe always 1% full only. Why? Because if you think of your mind as always lacking or not filled up, that means you're open always to receive more intellectual sustenance from the universe, you see? Okay, blessings. Thank you for watching.